Hey guys, we're going to do 26 and 27. So let's do it. It says derive using similarity the fact that the length of an arc intersected by an angle is proportional to the radius. Define the radian measure of an angle as a constant proportionality and derive the formula for the area of a sector. Okay, so there's a lot going on there. Let's dive in. Okay, it says, what is the area of this sector? So I don't want the area of the whole circle, right? I just want the area of a sector. So that's a portion of it. So if the arc length is 42, then the central angle is 42. And that's what I want. I want 42 tiny little slices out of a total of 360 tiny little slices. And I hope that makes sense. And that's the portion of the whole circle that I want. So the whole circle is pi r squared. So if you have trouble remembering these formulas, they aren't provided, but you can look back here on the cheat sheet, and we got a new cheat sheet today, and see how it says the area of the sector is the portion of 360 times the area, right? So that's what we did. We did 42 over 360 times the area of the circle, which is pi r squared. If you forget that, it's up there. Now, will these be provided on the test? No. But again, we're using them, and hopefully you're over the next 2 to 3 days, you're going to be memorizing them, and you just do enough problems where you start to have them memorized. Okay, so what is the radius? 8. So we have 42 over 360 times pi times 8 times 8. Now, we see in our answer, all of our answers are in terms of pi. So they want us to leave that pi part alone. So we're going to do 42 times 8 times 8. Well, 8 times 8 would be 64. So 42 times 64 all over 360 and then the pi. All right. So let's see. Let's see what we would get. So 42 times 64 divided 42, 64. So 2668. Divide by 360 pi. Well, I don't have any of these. So I have to reduce the fraction. I can also turn this front part into a decimal and see which one matches my decimal. 2688 divided by 360 is the decimal 7.46 repeating. So it's 7.46 repeating pi. So which one would have the same decimal? So this one's definitely, that's less than 1, so it's not that one. 28 over 15. No, that's not it. 60 over 7. Nope. So it's got to be this 112 over 15. Yep. Okay, so we found our answer. So what if it wasn't multiple choice? We had to reduce the fraction. So notice we see that both are even. Both have even numbers. So we could reduce the fraction by dividing it by 2. So this would be an equivalent fraction of 1344 divided by 180 pi, right? I divided by 2 on the top and bottom. And then I notice they're still even. So I'm going to divide by 2 again. So I get, there. That would be half of 180 is 90. And 344, what is that? 1344 divided by 2, 672. And notice they're both even again, so we can keep going. Just keep going, divide by 2, divide by 2. So half of 90 is 45. Half of 672 is 366. Or excuse me, 336 pi. And then you're like, wait a minute, this would have a 3 in it, and this would also have a 3 in it. So I can divide this one by 3 and that one by 3. So I get 1112 pi over 45 divided by 3 is 15. Aha, I finally got it after reducing the fraction. Phew. Okay, now you can see why I do it, if I have a calculator, the decimal way, so it's faster. Now it's saying, what is the length of PR? So this. So I do not want the whole circumference, not all the way around. I only want a portion of it. So what portion of it? Well, it's the angle here. But they want it in radians. So they're saying the angle measurement is 2/3 pi radians. So looking at my reference sheet, what is an arc length but in radians? So let's see if that's on here. I don't see it. You don't see it? Okay, so if you forgot or you can't find it, you can always Google it. So we'll go Google. Arc length formula in radians. So it's S, or the arc length, is equal R times theta. So it's actually an easier formula than you think. The arc length S is equal to theta times the radius. Okay, so back to our problem. Arc length is the theta times the radius, so the arc length is theta, if this is in radians, and then times the radius, which is 8. Okay, so like the last question, I don't want to reduce my pi, so I'm going to leave that out there. And I have 2 times 8, which is 16 over 3. There we go. I found my answer. So I want to add this, and I did, right? I'm going to add that this is in radians. So that's a different measure instead of degrees. Just like feet is a different measure than inches or centimeters. It's a different type of measurement. Okay, question number 3. In a diagram below, the circle shown has a radius of 10. The arc intercepted with it has a length of 2 pi. Okay, what is the measure of angle B? So I don't want the whole thing, right? I just want the sector, right? So this, or the, I just want this arc length, right? This arc length is 2 pi. The angle theta is B, that's the one we're solving for, theta, and the radius is 10. So doing a little Lynch swap, I can move this 10 down below, or you can think about just dividing by 10 on both sides. I get 2 pi over 10 equals theta, and this will reduce, dividing the top and bottom by 2, I would get 1/5 pi. That's the same as this. Right? There's 1 pi on the top and a 5 in the denominator. We find our answer using the same formula. Question number 5. Now we're not in radians. I'm just in regular old degrees. Find the area of the shaded part. Okay, so there's a couple ways I could do it. The central angle of my shaded part is not 60. It's what's left over from 360. So my central angle is 300. Okay. So my arc length is the portion of the area I want. 300 divided by 360 times the area of the whole thing. That's pi radius squared. So it's saying here they want to call the radius x, so I'll put that. And we know the area of the sector. The area of the sector was given to us, 15 over 2 pi. Okay, so doing a lot of Lynch swapping, we're going to try to get x squared by itself on one side. So I'm going to move this pi down here. Right, so I have 15 halves pi over pi. Move the 300 down here, right? And I'm going to move the 360 up here. Got it? So we got a lot of stuff that cancels here. I'm just going to copy this so you can kind of see what's going to cancel and what won't cancel. These pi's should cancel, right? And this 10, if I divided by 10 on both sides, this would be 36 over 30. And what else could I cancel? Let's see. If I divided by 15 on both sides, I would get 36 on top and a 2 and a 2 on bottom. Half of 30 is 15. Okay, so it looks like I'm just going to get a regular old answer. 36 divided by 4 is 9. Cool. Now, could I double check this? The answer would be yes. Is 300 divided by 360 times pi times 9 squared going to equal 15 halves? So would all this equal 15 halves? 9 times 9 times 300. 9 times 9 times 300 divided by 360 is times 300. Hold on. 9 times 9 times 300 divide by 360, 67.5. Hold on. I'm getting a different answer, so I want to double check this. Okay, so I'm going to cancel this. Let me just multiply the numerator and or maybe I could cancel here. This would be, divide by 2 would be 180 and divide by 2. So I have 15 times 180. 15 times 180, 270. Divide by 300. Oh, I know what I didn't do. This is just x squared, so I still have to take the square root of it. So 270 divided by 300. And then I need to take, now we're talking, and then I need to take the square root. $15 times 180. There we go. 2,700 divided by 300, we get 9. And so x squared is 9, which means x would be the square root of 9 or 3. Beautiful. That's our answer. Awesome. Okay. An arc on a circle of radius 10 has an arc length of 49 over 9 pi. What is the measure of the corresponding central angle? So this arc length, 49 pi over 9. If the radius is reduced to 2, is the arc length still possible? So I don't know if they want it in radians or, so we'll just do it this way, right? The arc length is 49 pi over 9. Theta, we don't know. We're going to solve for that. And the radius is 10. Then we can divide by 10 on both sides. Right? And we get 49 over pi divided by 90. And that's our angle. Okay? If the radius is reduced to 2, is the arc length of 49 pi. So it's like, no, that's a lot smaller, right? Your circle got smaller, so the portion of your circle has to get smaller. No. The arc length is not possible since the circle got smaller. Okay. 6. 3 concentric circles with a center of 0. KL is equal to LN is equal to NO. Okay, so they have the same radius. KP, the whole thing is 42. So it looks like this cut this into 6 equal pieces. So that means if I divide by 6, each of those are 7. What's the closest to the area of the shaded region? Oh, this is kind of a cool question. So I want to find the area of the whole thing. So the area of the whole thing is pi radius squared. And the radius of the whole thing is 3/7 or 21. 21 squared. So pi times 21 times 21. Okay, now I want to cut that in half because I don't want the area of the whole thing. I only want half of it. So I'm going to cut it in half. So this is the area of my semicircle. Now I still have to subtract off a half of the smaller circle. So that what is the area of my smaller semicircle? Well, that would be the area of the whole thing. Well, the area of the whole center circle is 7 squared. And then I want to cut that in half. So I need to take this number and subtract, see how this was cut out of it. And they want us to approximate. So I got 21 times pi divided by 2. So 21 times 21 times pi divided by 2, 692.7, 692.7, and I'm going to subtract 7 times 7 times pi divided by 2. 7 times 7 times pi divided by 2. I get 76.97. 76.97. Okay, and if I subtract the two, 692.7. 692.7, I get 615.7. Let's see if 615.7, yes, 615.7, which would round to 616. Cool. Now to the next page, 27. Given the informal argument, find for the formulas of circumference, area, volume, and pyramid, use dissection to arguments regarding cavallari and informal limits. Okay, so 2 stacks of 23 quarters, one stack forms a cylinder, but the other doesn't. We know these have the same volume if, using Cavallari's formula, they have the same height, and if this is the same cross-sectional area. And that would mean they'd have to have the same radius. Use Cavallari's principle to explain. So since these are same height, 23 quarters high, and same cross-sectional area, one quarter is equal to the other quarter. That's the cross-sectional area. Then they'd have to have the same volume using Cavallari's principle. Cool. Question number 2. According to Cavallari's principle, under what conditions are the volumes of 2 solids equal? When the cross-sectional areas are the same at every level, when the cross-sectional areas are the same at every level, and the heights are equal. Yes, this was the principle we used on the other one. Okay. All right, number 3. Alejandro cut a circle with a circumference of C and a radius of R. So he ended up cutting this circle into 8 congruent sectors. I'm about to have pizza, so this kind of makes me think of pizza, right? This is one. Like, do you see what they're talking about here? It's really interesting what they're talking about here because they're talking about approximating area by using the area of a parallelogram. This is very interesting, and I've seen this on tests come up before, so I really like the concept because I like this idea of approximation. In engineering school, you use approximation a lot. Okay, so he cut a circle with circumference C and a radius of R, and so that's this length right here, into 8 congruent sectors and use them on the figure. Alejandro noticed that the figure was very close to the shape of a parallelogram. Select all the statements that apply. The height of the parallelogram is approximately, right? This would also be the radius, right? The center to the edge. The height of the parallelogram is approximately equals to the circle's diameter? No, the radius. The radius of the circle is approximately equal to the height of the parallelogram. So this was what we were looking for. The area of the parallelogram is approximately this big, ugly formula. So let's see. 360 divided by 8 equal pieces. 360 divided by 8 equal pieces is 45. So that's where that number 45 is coming from. So they're saying if the area of, I think I like this, if the area of a sector is 45 divided by 360 times radius squared, and we have 8 of those pieces, then that's a good way of approximating this parallelogram made. I agree. The length of the parallelogram is approximately equal to the circle's circumference. Well, notice, let's track this using another measuring tool. So the circumference is here, right? Here, right? Here, and another blue one here. That's the length. So it's not. The length is approximately equal to half of the circumference. So I'm going to go no. The area of the parallelogram is equal to 1/2. Aha. Yeah, the area of the circumference is base times altitude. And we said the altitude was r, right? And we said the base was half the circumference. So this is exactly what we did. So that's a big yes. The length, so we already, yep, so that's it. We got those 3. Very cool question. Last one, 2 cylinders are a sphere and a cone. Select the 2 objects with the same volume. Okay, so, you're going to fall for that? Hopefully not. That's my radius, right? So this would have the volume is the area of the base, so pi 1.5 squared times the height of 4. So you'd have 4 times 1.5 times 1.5. 4 times 1.5 times 1.5. So that's 9 pi. So this is 9 pi. Here you have the area of the base, pi 4 squared times the height divided by 3 because it's pointy, right? It's a pyramid. So yeah, this is not going to be the same. So 4 times 4 is 16. 16 times 2 is 32. So 32 thirds pi. Here we have our sphere. So that would be 4 thirds pi. And you don't fall for that. That's our diameter, right? So our radius is 2. So 2 cubed. So 2 times 2 times 2 is 8. 8 times 4 is 32. Over 3 pi. Interesting. So as of right now, this one and this one are a match. All right, let's do this last one. Don't fall for that diameter trick. Remember, we're too smart for that, right? This is the radius. So the area of my base is pi 1 squared times my height of 6. All right, so this would be 6 pi. Yep, so we found them. These two are the same volume. Well done, guys. See